Well, now let's talk about the gas system in Ethereum. As I already said in one earlier video, whenever you modify the blockchain, so if you send tokens, interact with a contract, send Ether, or do anything else on the blockchain, you must pay for that computation. That payment is calculated in gas, and gas is paid in Ether. Why do we need this gas system? Well, you can compare this with Amazon Web Services, for example. This is also not for free. You need to pay for storage on the servers. In the world of Ethereum, we do not pay Amazon, but instead we pay the miners with gas. More precisely, we pay for every single line of code. For example, if we have a look on our code, let's take all tokens equals all tokens plus tokens, and tokens equals MSG value multiplied with 100. In this list, you can see how much every single operation cost. In our example, the 2 lines of code would cost 3 gas for addition plus 5 gas for multiplication. So in total, 3 plus 5 is 8. So this is basically for what you pay. But how does this look like in practice? So for example, when we create a transaction, well, if we create a transaction, we need to distinguish 3 properties: the gas price, the gas limit, and the actual transaction costs or fee. To get a better idea how this is used in practice, let's pivot to this tab. I'm here on etherscan.io. So the Etherscan of the mainnet. I have here a random transaction from someone who has sent 0.2 Ether to this address. So let's talk about the gas price. The gas price is the amount of Ray we are offering per unit of gas. Based on this example, if we are willing to pay a gas price of 10, that would be 10 times 8, so 10 Ray per unit of gas. In other words, the gas price would be 80 Ray. The price you pay for each unit increases or decreases how quickly your transaction will be mined. The more you are willing to pay per unit of gas, the faster the transaction will processed. Next, we have the gas limit. This is the maximum amount of units of gas the sender is willing to spend on a transaction. By default, a standard transaction costs at least 21,000 gas. This is a good example here because the spender used a gas limit of 90,000. But as I already said, a default transaction like this costs only 21,000 gas. So the actual gas consumed by the transaction was 21,000. In this case, all unused gas is refunded to the sender. So the 90,000 minus 21,000. What happens if you spend less than 21,000 as gas limit? Well, then you have a problem, because you will lose all your gas and the transaction won't be executed. Because that the miner is even able to detect the transaction, you need to pay for that. And the last property we can find in all transactions is the actual transaction fee. This is simple, because this is just the gas limit multiplied with the gas price. In this case, it's this multiplied with 21,000. Okay, that's everything for the gas system now. And in the next video, we will continue with our ICO code.